All right. So today we're going to talk about how to solve equations with variables on both sides of the equal sign. Okay, so up until this point, all of our variables have either been all on the left side or all on the right side. Okay. You're going to use the same inverse operations to move things to one side or the other. Okay, so for instance, if I want to move the 6t over to the other side, okay, the 6 is positive, so I'm going to subtract 6t from both sides. Notice how I write it underneath the other number that has a variable with it, because 6t and 5 are not like terms. So 8t minus 6t is 2t. I still have the plus 5, I didn't do anything with that, and I still have this plus 1 on the other side. So now again, we've related it back to a problem, a type of problem that we have done before. So then I'm going to subtract 5 from both sides. We get 2t equals negative 4. And then divide by 2. So t is negative 2. Again, we can always go back to that check and make sure we did it correctly. That's what we're trying to figure out if we got it right. So 8 times negative 2 is negative 16. Plus 5 would be negative 11. 6 times negative 2 is negative 12. Plus 1 is negative 11. We got the same number on both sides of that equal sign. So we are good. We got the right answer. Okay. So this combines our distributive property and variables on both sides. Okay, so guys, don't try and subtract the a first, okay, because remember, multiplication has to happen first. So we have to use that distributive property. So 6 times a is 6a. 6 times 4 is 24. So then this side only has a's on it, so I'll probably move all of my variables to that side. So I'm going to subtract 6a from both sides. So 3a equals 24. And then divide both sides by 3. A is 8. Okay. Let's do the next one. Same kind of thing. We need to distribute first. So I get 8m equals 4 times 2m is 8m. 4 times 1 is 4. So again, got variables on that side, so probably going to use that side. So I'm going to subtract 8m from that side, subtract 8m from that side. 8m minus 8m is 0. So I end up with 0 equals 4. Okay, guys, this you can't solve. So if you ever get a situation where it's 0 equals 4 or negative 2 equals 7 and they're not equal on both sides, this is what we call no solution. Okay, so what that is telling me is I can't find an m value that if I plug into both of those, I would get equal pieces on both sides, like we did in the example above where we got negative 11 and negative 11. Okay. All right, next one. This time we have to use distributive property twice. So 4 times 3x is 12x. 4 times 2 is 8. 2 times 6x is 12x. 2 times 4 is 8. So again, I'm going to get my variables on one side. So we're going to subtract 12x from both sides. Okay, so 12x minus 12x is 0, so I still have 8 on this side. 12x minus 12x is 0 on that side. I still have an 8 on that side. So this, okay, is different than this answer, right? Okay, because 0 definitely did not equal 4, but 8 does equal 8. Okay, so this is an example where we say it's all solutions. Okay, so what that means is I can pick any value of x that I want, whether it's 10, whether it's negative 25, plug it in for my x's, and I will get the same thing on both sides. Okay, so that means there's not one specific x that I can pick that would make it true. All right, now it's time for you to try one on your own. Okay, so this will kind of work a little bit like the first example that we did together. Okay, put it in your notebook. We'll talk about it tomorrow. Come ready to share if you have questions.